Winds on Mars can both help and hurt spacecraft. So we're getting really creative in how to study winds on the surface of Mars over a large region.
We're here at NASA's Jet Propulsion Laboratory in the Space Flight Operations Facility, also known as the Dark Room. This is where engineers send commands and receive data from JPL missions, including NASA's Mars Reconnaissance orbiter. Now, detailed images from the orbiter are helping scientists better understand Martian winds. Leslie Tamppari is MRO's Deputy Project Scientist. Leslie, what are we seeing in these images?
So what you can see here are dark patches on the surface of the ice near the South Polar region. And they're created by gas jets that come from under that ice up through cracks and deliver that dust out onto the ice. And the wind will carry that dust and lay it on the surface, forming these fans. And what we can do with this information is we can look at the directions and the sizes, and we can try to understand what the wind field is doing.
And I understand that volunteers played a large role in this research.
Yes, they did. We have taken about 75,000 images over all of Mars with our MRO HiRISE camera. We used citizen scientists, 80,000 volunteers, to map these fans and map their directions and sizes.
Why is it important to study wind direction on Mars?
Some of our landers and rovers have had wind measurements, but only in a few locations at a few different times. But winds are very important for understanding today's climate on Mars, but also for trying to understand how the climate was different in the past. We also have huge dust storms that occur on Mars sometimes. But we don't understand why some storms become global and some don't. So we're trying to understand the wind field to try to put all these pieces together to understand Mars better.
And how does that information help protect NASA's spacecraft?
Right, it's very important for not only the spacecraft, but probably future human exploration as well. Because dust, it can be dangerous to hardware. For example, on the Perseverance rover, we're fortunate enough to have a wind sensor, and we're measuring dust devils. And a couple of these dust devils and wind events were so large, they picked up not only dust, but bigger particles, sand-sized particles. And in fact, some of the wind sensors were damaged on the Perseverance rover. In other locations, we see hardly any dust devils. For example, the InSight lander has solar panels. The solar panels are completely covered with dust, and so the power is waning, and we'd really like to see some dust devils coming by so that they could clean off those solar panels and provide InSight with some more power. So learning about the winds and the different environments and how they change across Mars will really help us plan not only for the conditions for today's spacecraft there, but also plan better for the future.
Thank you, Leslie. To get the latest updates, follow at NASA JPL and at NASA Mars on social media, or take a deeper dive on the mission websites at mars.nasa.gov.